Okay, hello everyone. So now I want to look at the fundamental theorem of calculus part 1. So this is one of the big theorems in calculus, and it tells us how to relate the integral and the derivative. So it says that if f of x, little f of x, is a continuous function on some interval from a to b, and we define the function big F of x to be the integral from a to x of little f of t dt. So again, remember this is the integrand here. So we're defining this new function big F of x. That's an integral from some constant a up to the variable x. And we're taking the integral of f of t dt. Well, then it says that the derivative f prime of x, the derivative of the big function, is just the little f of x over the interval from a to b. So the derivative of the big function is just the little function, or the derivative of the integral is just the integrand, little f of x. So let's see this in practice. Let's say that I have the integral, or let's define the big function f of x to be the integral from 0 to x of t cubed dt. Well, here, the integrand is just t cubed. So the fundamental theorem of calculus says that the derivative of big F of x is just x cubed. Okay, it's just f of x. So for 2, we have g of x is defined to be the integral from 1 to x of e to the sine of t. So in this case, little g of t, I guess, is e to the sine of t. And in this case, big G prime is just e to the sine of x. So that's really straightforward as long as the integral is written exactly in the form as stated in the fundamental theorem of calculus. So as long as it's a constant up to the value x, then e to the sine of t dt, if you take the derivative of that, you get just e to the sine of x. So part 3 is maybe the hardest part of this video, and it's looking at the integral from 1 to x cubed of e to the sine of t dt. So the only thing that changed here is that now we don't have just x there, we have a function of x, we have x cubed. So let's see. Otherwise, this looks just like g. So if you look at these two functions, compare them, h of x looks just like g of x, except for instead of having an x here, I have x cubed. So let's let u of x be x cubed. Well, then this is just the integral from 1 to u of e to the sine of t dt. So what could I say then? I could say that h of x is just g of u of x, okay? Right, because this looks just like g now. So if I plug in a u there, then I get this, right? Well, then I can use the chain rule, right? We remember what the chain rule says about derivatives. It says that if I want to find h prime of x, that's just going to be g prime of u of x times u prime of x. So what's u prime of x? Well, u prime of x is, if u is x cubed, u prime of x is 3x squared. So I guess this last one, to calculate h prime of x, we needed to take g of u of x. Well, that's just e to the sine of u of x times u prime of x. Well, what's that? E to the sine, u of x was x cubed, so e to the sine of x cubed times u prime of x. U prime of x is 3x squared. Okay, so that's about as hard as these problems get, is that you might have to do a chain rule to fix this bound up there. And otherwise, it's relatively straightforward. So I hope that was a helpful video. Have a great day.